Good afternoon. My name's Pete Spillard and I'm Managing Director of Spillard Safety Systems. 20 years ago, an unfortunate meeting with a health and safety inspector on an open cast coal site led us to a company in Gloucester that manufactured blow moulded plastic products. These products would eventually become a range of convex mirrors that could naturally maximise visibility on earth moving equipment. These all-round vision products would assist drivers to operate machinery safer for the next 20 years. However, initially, when we started talking about all-round vision, unless we could actually get a set of the convex mirrors onto a machine to demonstrate the actual concept, the initial understanding of all-round vision, we're talking 20 years ago, I was 19, it was difficult to get that understanding across, and the term all-round vision was totally in its infancy. To demonstrate the concept, we developed machine-specific visibility studies to highlight the areas of extended vision through convex mirrors. But this in turn actually created blind spot maps, or the areas of restricted visibility. What I'm going to go through now is, over the years, we've carried out over 200 of these studies on all different types of vehicles. So I'm just going to go through quickly a few examples of them. What we've actually got, the study itself, each of these squares represents half a metre. Now this is a typical telescopic handler load all that you would see on a site. The area of blue is the area of blind spot at a metre high. So on this machine, when you're sat in the driving position, your blind spot is probably 9 metres to the front, 2-3 metres to your offside, and around about 7 metres to the rear. So it's quite a large blind spot, or natural, where your vision is restricted into the area. Wheel loader. This one's a lot better. You've only got your vision, or your area of restricted vision at the rear. Around it is less than a metre. So natural vision around the machine is quite good. We started to also include things like the areas of vision through the OE supplied mirrors. So it gave you an idea of where they were actually trying to cover with the flat mirrors, the flat glass mirrors. Excavator, probably about 20-25 tonne. Again, area of blue is your area of blind spot at a metre high. So offside, you're probably talking 4.5 metres. To the rear, where the A is, about 12.5 metres. Typical tractor and bowser that you would see on your site, pulling dust suppression. To the front, I don't know, 2 to 3 metres to the front. Over the wing mirrors, again, you've got about 1.2, 1.5 metres. And then to the rear, you've got the blind spot that's created by the actual bowser. Articulated dump truck, same again. The blue area is your area of blind spot. Starting to increase now with the size of machine and the size of area of blind spot that's being created. So to the front of that machine, you've got 5 metres, at 1 metre high that you can't be seen for. To the left and right, about 1.5 metres, 2 metres, and then to the rear is your infinite blind spot that is created, well, just because of the skip there. Again, to point out, these are the mirrors that are supplied by the manufacturers to remedy the blind spots. On that machine, we've got 1, 2, 3, 4, 5, 6, and one there, 7, 8 mirrors to try and give us visibility around the machine. Obviously, we've got a few areas that are actually lacking. Starting to go up the scale now, 75 to 100 tonne. Again, area of blind spot is the blue area. Mirrors that are provided to cover the areas of blind spot by the manufacturers. To the front, around about 3.5, 4 metres. Offside, we're talking, I don't know, 7, 8 metres. Now the interesting part is, this is rigid dump truck. We sit on the left-hand side of the rigid dump truck, but the area of blind spot on the driver's side, where he actually sits, is now nearly 3 metres. So 1, 2, 3. So that's the area of blind spot, the metre high, which is something that we've started to understand, or starting to get to understand. Another 100-ton dump truck, starting to change this time because of the areas of the actual, or the shape of the actual machines. So you've got a nose cone on the front of this machine, so it's creating a blind spot around here. To the front, we're talking probably 5, 6 metres, 7 metres at the maximum. Offside is around about 10 metres. But these areas, as I say, are created because of the shape of the machine and the way that the machine is actually designed. Again, on the driver's side, where we actually sit, we're up to about 3 metres of blind spot. And then the rear is quite infinite. Now on this one, this was a standard study with the machine actually arriving on site. A little bit more proactive on the visibility. So red areas are the standard mirrors that are supplied by the OE to try and cover or remedy the areas of blind spot. Taking it to the maximum in this country, this is a CAT 785, probably 150 tonne. Not many of them running at the moment, but as you see, blind spot has increased with the size of the machine. To the front, we're talking 6 or 7 metres, driver's side probably 4 metres. Offside, it's infinite. And these are external sources that are causing the areas of blind spot. So it's things like the air conditioning units, the placement of mirrors, the placement of fire extinguishers, the placement of access, the placement of the handrails are starting to create these areas of blind spot, which if you think that that's a 2 metre square blind spot at the front of the machine, we can have a person standing, kneeling in that area, which isn't going to be seen. So why are we still talking about visibility today? Quarry fact files in 1996, 2000, 2005 have highlighted the need for visibility or improvements to visibility. More recently, QNJAC, Safer by Design, are pushing for greater visibility. So why? Why are we still talking about it? It's because visibility-related accidents are still happening, whether that be on a coal, quarry or construction site, or even the delivery vehicles travelling between those sites. We're still having the accidents. Now, we've been using the visibility studies as tools for selecting the correct aids to improve visibility for years. Yes, we've increased the operator's vision, reduced the blind spots, and improved their all-round awareness, but have we actually failed? Accidents are still happening. The studies along the years have been exclusive, maybe even limited to plant and quarry managers. At some times, the operators might have been included in those discussions. But was this right? In hindsight, probably not. Everybody needs to understand visibility, or the lack of it. Not limited or restricted. Everyone from site workers through to management, directors through to subcontractors, everybody. Everybody needs to understand visibility, needs to understand what blind spots we've got around these machines before we start going into these areas that we perhaps should have segregated people from. Now, have machines changed over the past 20 years? The advantage with me carrying out, or us carrying out these visibility studies, is that we can compare. Well, actually, the machines have got worse. EN 474, through ISO standards, have enforced more ergonomic designs, lower emissions, lower noise, thus creating larger engine bays, more insulated cabs, resulting in lower, more ergonomic driving positions and potentially larger, deadlier blind spots. Yes, we've got ISO standards to counteract our visibility, but what we've actually lost is the natural vision. So what I'll just do now is run through a few comparisons. So we've got the telescopic handler on the left. This study was carried out around about 2000, following a fatality on a site. I sometimes get called in by our customers to understand what the visibility is on that machine following fatalities. I don't get to see the machines, but I get to see something similar. So this was a telescopic handler 2000, so we're talking 13 years ago. So area of blind spot again is the blue area. This one on the right is a telescopic handler that I carried out a visibility study on 3 months ago. Now the area of blind spot to the front of that telescopic handler is 43 metres. Now where the A is at the moment is 14 metres. So the actual blind spot in front of that telescopic handler with the boom in a carrying position at 500 mil off the floor is 3 times that length. So we're talking probably up here somewhere. That is the size of blind spot on a telescopic handler that is coming out of the factory today. Yes, we've got blind spots on the rear and that's increased, and yes, we've got it to the right, and yes, there's products on there to probably remedy it, but natural vision, and I keep going on about natural vision is what we should have, because from day one we are trained to operate a machine to be able to look round it. We don't look into a mirror or a camera, we're here, we're sat in a machine and we're looking around our machine. That's what we're trained to do. So that area of vision has lost. Excavator. It's about a 15-ton excavator. Visibility study on the left-hand side again has been carried out probably 10 years ago. One to the right I did about 6 months ago. Area of blind spot is just, well, you can see the two. There's the comparison. Dozer, typical, probably about a D6 size. One to the left is one I probably carried out, again, 10, 11 years ago. One to the right was carried out about 6 months ago. So the areas of blind spot has increased. I go back to why. It's the isolation of the cabs, external sources that have been fitted, air conditioning units, whatever's been added has increased these areas of blind spot. This is a soil compactor. I did this 2001 on the Birmingham Northern Relief Road, or M6 toll, which it is now. This is a soil compactor that I carried out again following a fatality. It was about 6 or 7 months ago. Increase in visibility, or the lack of visibility. I think the thing that surprised me the most is that the machine was designed ergonomically for you to sit in a position where you had a hand on the steering wheel and a hand on a lever, yet it didn't lend itself to look round. You just sat there, you just didn't want to turn around in the machine. There was no mirrors on it, and there was no reversing camera. Now, this one that I went out to, the supplier of the machine had put mirrors on prior to me arriving. Now, if the machine isn't designed for us to naturally look round, and there's no products or ways of limiting that risk, then what are we doing? Where are we going? This is a wheel loader. One on the left again is probably 10, 15 years old. One to the right I carried out about 2 months ago. They're actually the same model of wheel loader. Yes, this one's got one letter after it and this one's got another letter after it, but they're still the same wheel loader. Blind spots that have been induced or increased here is through size of engine bay, size of the air conditioning units have been fitted. So, yeah. So where do we go? Where next? Radical redesigns, 20 years of discussions and revised ISO standards have got us nowhere. In fact, as we've seen previously, we're actually in reverse. Excuse the pun. Technology, like Optronics 360, where we stitch together 4 187-degree cameras that produce the ultimate surround view. Maybe. But really, they should only be used in a combination with other measures. The installation of mirrors, the proximity alarms, then vehicle segregation, safe systems of work. Not just relying on technology. Education. Definitely. Well, I believe so. Promote the issues of blind spots from day one. Not just in construction and quarrying, but all transportation industries. Keep that message in front of the exposed persons day in, day out. Use the toolbox talks that we use. Use the safety days. Use the support of the IQ, the MPQC and the MPA. And together, we probably can kill the blind spots before the blind spots kill again. Thank you for listening.